In July 2025, astronomers spotted something racing into our solar system from the stars beyond. At first, it looked like just another comet. But almost immediately, whispers began. What if it wasn't natural at all? What if it was built? Within days, headlines around the world exploded with claims of alien technology, forcing NASA to step in with answers. But the real story of this object, the third interstellar visitor ever discovered, is stranger than the hype. Because buried in its chemistry are secrets from another solar system, billions of years older than our own. It didn't take long for the discovery of 3IATLAS to spark a firestorm of speculation. Astronomers across the world were excited, but one voice stood out above the rest. Harvard astrophysicist Avi Loeb. Known for pushing bold ideas, Loeb had already made headlines years earlier by suggesting the first interstellar visitor, Oumuamua, might have been more than just a rock. Now, with ATLAS, he saw a pattern he couldn't ignore. At first glance, the comet seemed to break the rules. Unlike most comets, it didn't immediately sprout a tail, that bright stream of gas and dust blown out by the sun. Instead, it looked faint, almost too faint, and its trajectory didn't quite match the textbook expectations. To Loeb, this was suspicious. He argued that if the object continued to show no outgassing, or if it changed direction while behind the sun, then maybe it wasn't natural at all. And that's when the story exploded. In blog posts and scientific papers, Loeb floated the idea that 3IATLAS could be artificial, perhaps a probe sent deliberately from another civilization. He even suggested, in the most extreme hypothetical, that such an object could carry hostile intentions. Of course, he admitted the more ordinary explanation was simply a comet behaving in unusual ways. But nuance rarely makes headlines. The media didn't lead with natural comet with odd chemistry. They led with alien technology, and Harvard professor says probe could visit Earth. The speculation raced across social media, fueled by a public eager for the extraordinary. After all, the idea that a visitor from another solar system might be a machine, possibly even designed by intelligence we can't yet imagine, is far more exciting than icy dust grains and carbon dioxide ratios. And for Loeb, this wasn't just about shock value. His point was philosophical as much as scientific. He argued that science should remain open to radical possibilities, that dismissing the alien hypothesis out of hand would close the door on discovery. In his words, ignoring such scenarios was more dangerous than considering them because history has shown the universe is often stranger than we expect. Still, whether he intended it or not, the word alien changed everything. Suddenly, 3IATLAS wasn't just a comet to the public. It was a mystery, a potential signal from the stars. And while the speculation made headlines around the world, NASA's scientists were quietly preparing their response. Unlike Loeb, they had direct observations in hand. And what those telescopes revealed would strip away the speculation and uncover the real nature of this strange traveler. While speculation about alien probes dominated headlines, NASA was quietly working behind the scenes to cut through the noise. They didn't need theories, they had data. Within weeks of 3IATLAS being detected, astronomers turned some of the most powerful instruments on Earth and in space toward the mysterious traveler. The Hubble Space Telescope, the James Webb Space Telescope, and a network of ground-based observatories all locked onto the object as it sped toward the inner solar system. And the results were clear. Whatever 3IATLAS was, it behaved exactly like a comet. As sunlight warmed its icy surface, the object began to change. First came the coma, a hazy shroud of gas and dust surrounding its nucleus. Then, unmistakably, a tail stretched out behind it, carried by the solar wind. These were the classic signs of a comet awakening under the heat of the sun. If this had been a piece of alien machinery, it was doing a very convincing impression of frozen rock and ice. Spectroscopic readings went even further. NASA scientists detected water ice and carbon dioxide venting into space. But there was a twist. The ratio of CO2 to H2O was unusually high. Unlike most comets native to our solar system, its dust grains also scattered light in distinctive ways, creating a polarization signature never seen before. This was new, yes, but new didn't mean alien. It meant 3IATLAS was formed in a different environment, under conditions no comet here had ever experienced. Tom Statler, NASA's lead scientist for small bodies, summed it up in one memorable line. It looks like a comet. It does comet things, and the evidence overwhelmingly points to it being a comet. In other words, the mystery was solved. The alien hypothesis had no support in the data. Equally important, NASA reassured the public there was no danger. The comet's closest approach would be 1.8 astronomical units, about 170 million miles from Earth. Its trajectory, carefully mapped, showed safe passes by Mars, Jupiter, and Venus with no chance of collision. For all the drama, 3IATLAS wasn't a threat. It was an opportunity. And yet the unusual chemistry raised a new question. If it wasn't alien technology, then what did its strange makeup reveal about the hidden worlds it came from? So if 3IATLAS wasn't alien technology, then why did it matter so much? Because this comet isn't just another icy wanderer, it's a time capsule, a frozen relic from a solar system that isn't our own. Every comet carries chemical fingerprints of the environment where it formed. And in the case of 3IATLAS, those fingerprints told a startling story. The dominance of carbon dioxide over water suggested it was born in a region of its home system far colder than anything we know here, a place where CO2 ice could pile up in abundance while water remained locked away. In other words, this comet is a messenger from the deep freeze of another sun, carrying chemistry we rarely encounter. Some studies even propose that 3IATLAS may have come from the Milky Way's thick disk, a region of ancient stars and planetary debris. If that's true, then this comet could be more than 7 billion years old, older than our solar system itself. Think about that. While Earth was still molten rock, this fragment of ice and dust may have already been drifting through the galaxy, waiting to cross our path. And the comparison to past visitors only deepened the mystery. The first interstellar object, Oumuamua, had no visible coma at all, sparking years of speculation about what it really was. Borisov, the second, looked like a textbook comet. Atlas, the third, fell somewhere in between. It developed a tail and outgassed like a comet, but with chemical ratios and light signatures, unlike anything astronomers had ever recorded. This diversity is exactly what excites scientists. Each interstellar visitor isn't just an isolated oddity, it's a data point in a much bigger puzzle. By comparing them, astronomers can test whether the processes that shaped our own solar system are common across the galaxy, or if our corner of space is truly unique. So while the alien headlines faded, the scientific treasure only grew. 3IATLAS isn't just a rock from beyond, it's a preserved fragment of another planetary nursery, a piece of cosmic history that has traveled billions of years to deliver its secrets to us. The story of 3IATLAS wasn't just about a comet. It was about how science itself unfolds. On one side, you had bold speculation. Avi Loeb pushing the idea that maybe, just maybe, this wasn't natural at all. On the other, you had NASA methodically collecting data, analyzing spectra, and building an airtight case for what it really was. At first, it looked like a clash, speculation versus evidence. But in reality, both played a role in keeping the story alive. Loeb's daring ideas sparked global curiosity, keeping people glued to the question, what if? NASA's careful observations provided the answer, showing us what the evidence truly said. That balance, imagination pushing outward, evidence reeling it back in, is how science advances. We ask wild questions, then test them until only truth remains. And the timing of this discovery showed just how far astronomy has come. A decade ago, the detection of a faint, fast-moving object from another star system might have gone unnoticed. Today, coordinated campaigns across the world, from ground observatories to space telescopes like Hubble and JWST, can capture these fleeting visitors in remarkable detail. Every dust grain, every spectral line, every subtle shift in brightness is recorded and studied. That means the next time an interstellar object swings through, astronomers will be ready, not only to silence unfounded rumors, but to squeeze out every drop of knowledge these cosmic messengers carry. Each one adds another piece to the puzzle of how solar systems form, evolve, and scatter their debris across the galaxy. So no, 3IATLAS wasn't a probe, it wasn't alien hardware, and it certainly wasn't here to spy on Earth. But what it offered us was something far more valuable. a glimpse into a world billions of years old, preserved in ice, drifting through the void, now close enough for us to study. In the end, the real wonder wasn't science fiction. It was the science itself. So in the end, 3IATLAS wasn't alien technology. It wasn't a probe from another civilization or a machine with hidden intentions. It was something even more powerful, a natural fragment of another star system, carrying secrets locked in ice for billions of years. What makes it extraordinary isn't speculation, but what it tells us about the galaxy itself. Its strange chemistry revealed that planetary nurseries out there can be wildly different from our own. Its sheer age hinted that solar systems were forming long before ours was born. And its very presence proved that interstellar debris doesn't just exist. It travels, it wanders, and sometimes it finds us. The alien rumors may have grabbed headlines, but the real story is bigger than that. Every interstellar visitor we detect, from Oumuamua to Borisov to Atlas, is a clue, a piece of a puzzle that stretches across the Milky Way. One day, by comparing these fragments, we may finally learn whether our solar system is typical or unique. And maybe that's the real wonder, because the truth is, we don't need aliens to make the universe mysterious. The universe itself, with its frozen messengers and ancient secrets, is already stranger and more breathtaking than anything we could invent. Want more discoveries like this explained clearly? Subscribe, stay curious, and remember, the universe always has another surprise waiting.